We are going to cover many aspects related to the public IP in this video. Let's unpack what the public IP is first. A public IP address is an IP address that is reachable from the internet. In Azure, a public IP address enables internet communication to resources within your virtual network by assigning a unique IP address to each resource that needs to be accessible from outside the Azure network. Azure public IPs are not tied to a specific region but are globally routable, meaning they can be accessed from any internet connected location. Public IPs can be assigned to various Azure resources such as virtual machines, Azure Load Balancer, and application gateways to facilitate internet communication. Why public IPs are essential for workloads in Azure? Public IP addresses allow Azure resources to communicate with the internet. For workloads that need to be accessible to external users or services like web servers or APIs, a public IP is essential for enabling that connectivity. Public IPs are often necessary for certain cloud services that require external access, such as third-party integrations, SaaS applications, or applications that provide services to users across the internet. Public IPs can be assigned to Azure Load Balancers, which distribute incoming internet traffic to multiple VMs or backend resources. This is crucial for high availability applications that need to handle large number of requests efficiently. Public IPs allow application gateways to serve as the entry point for web applications. They enable secure, managed, and scalable access to web applications from the internet and support features like SSL termination, traffic routing, and application firewall protection. For remote access solutions such as VPNs, public IP addresses allow users to connect securely to Azure resources from remote location, which include on-premise networks or individual devices. Azure allows you to control access to resources with public IPs using network security groups and firewall rules and ensure that only authorized traffic reaches your resources. This capability is essential for securing internet-facing workloads and reducing exposure to malicious traffic. Though public IPs facilitate internet communication, it does not mean that you allocate it to the resources when needed. No, not at all. There are few considerations you should have while working with public IPs. Only assign public IPs when absolutely necessary. For internal workload, use private IPs to reduce exposure to the internet. And the more you open up your workload to the internet, your depth in defense strategy will always need to have many other considerations. You should always use NHGs, firewalls, or application gateways to restrict access to resources with public IPs and limit the attack surface. For workloads exposed to the internet, consider using Azure DDoS protection to protect against distributed denial of service attacks. In essence, public IP addresses are essential in Azure when a workload requires direct internet access, load balancing, remote management, or secure managed connectivity for applications. No worries, Azure provides flexible options to ensure you can use public IPs securely and efficiently. In Azure, public IP addresses can be created using either IPv4 or IPv6 formats. And you have the flexibility to choose between dynamic or static allocation methods based on the needs of your workload. A dynamic public IP automatically assigns when a resource like a VM is created or started, and it can change over the resource lifespan. The IP address is released back to Azure when you stop or delete the resource, meaning a new IP may be assigned when it started again. Each Azure region has its own pool of public IPs, and the default allocation method is dynamic. Static public IP is fixed and does not change over the resource lifespan and makes it ideal for scenarios that require a consistent address. When you explicitly set the allocation method to static, Azure immediately assigns an IP that stays with the resource until you delete it or switch the allocation method to dynamic. Choosing between static and dynamic IPs depends on your requirement. Use static IPs for services needing a permanent address and dynamic IPs when a fixed address isn't essential. You can only associate public IPs with few Azure resources that includes virtual machines network interfaces, virtual machine scale sets, public load balancers, virtual network gateways, NAT gateways, application gateways, Azure firewall, Bastion host, and the route server. Choosing the right SKU for a public IP address in Azure can have a significant impact on your application's performance, security, and availability. Let's discuss the difference between the standard and basic SKUs. For allocation method, standard always uses a static allocation method, meaning the IP address doesn't change once assigned, whereas basic allows flexibility. For IPv4, you can choose either dynamic or static allocation. For IPv6, only dynamic allocation is supported. For idle timeout, both SKUs have inbound idle timeout range of 4 to 30 minutes with a default of 4 minutes. This means if there is no activity, the connection may time out within this time frame. Both also have a fixed outbound timeout of 4 minutes. For security, standard SKU is secure by default. Inbound traffic is closed unless explicitly allowed with a network security group. For instance, if used with a virtual machine, you will need to set up an NSG to manage traffic. Whereas basic SKU is open by default, meaning it doesn't require an NSG, though adding one is recommended for traffic control. For availability zones, standard SKU supports availability zones, which allows for greater resilience. You can create zonal, non-zonal, or zone redundant IPs in the regions with 3 availability zones. However, older IPs in such region might not support zone redundancy, whereas basic SKU does not support availability zones at all. For routing preference, standard SKU provides routing preference to control how traffic flows between Azure and the internet, which offer more control over traffic routes, whereas basic SKU does not have routing preferences. For global tier, only the standard SKU supports a global tier of IP addresses, which enables cross-region load balancing for global applications, whereas basic SKU does not support this feature. Overall, standard SKU is better suited for high availability, secure, and globally distributed applications due to its advanced security, availability zones, and routing features. And basic SKU may work well for simple application where these advanced features aren't necessary. In Azure, public IP address prefixes and custom IP address prefixes, which is BYOP, provide control over IP address allocation and enable organization to tailor their networking for high availability, resilience, and familiarity with existing address space. A public IP address prefix in Azure is a reserved range of contiguous IP addresses configured per region and subscription and will offer control and predictability in IP allocation. To create a public IP address prefix, you specify the size of the prefix. That means number of IP addresses in the range, its name, and any desired association with availability zones. Prefixes can include IPv4 or IPv6 addresses. In regions that support availability zones, these prefixes can be zone redundant. That means can span across multiple zones or bound to a specific zone to enhance fault tolerance. There are a number of use cases that gets enabled because of this capability. Using a predefined range simplifies managing IPs, especially when scaling applications with predictable IP addresses. For applications requiring high availability, zone redundant IP prefixes ensure resilience by spanning multiple zones. And since the prefixes are regional, organizations can assign specific IP ranges for resources in various regions, streamline network segmentation, and resource grouping. The custom IP address prefix, also known as bring your own IP, allows the organization to bring their own pre-owned IP address ranges into Azure. This option gives them continuity and control over IPs they have already used externally or in any other environment. Organizations bring in their own IP prefixes, which Azure treats like a Azure own public IP prefixes, meaning these custom prefixes integrate seamlessly into Azure's networking model. BYOIP has same usability as Azure own prefixes. Addresses from a custom prefix can be assigned to Azure resources, interact with virtual networks, and reach external networks over the Azure wide area network. These IPs work for both internal interactions with private IPs or virtual networks and for reaching external networks and provide a consistent experience. There are a number of use cases that gets enabled because of this capability as well. First, beauty is organizations can retain familiar IP ranges across environments, which help clients recognize traffic origins more easily. For organizations migrating to Azure, BYOIP reduces the complexity of changing IP addresses, simplify transitions, and preserve dependencies on known IP ranges. And retaining existing IPs enables organizations to keep security policies and access controls that are already in place without significant reconfiguration. In essence, public IP address prefixes in Azure allow for scalable and region-specific IP allocation with high availability through zone redundancy, while custom IP address prefixes empower organizations to maintain consistency and familiarity with existing IPs, which simplify migration and ensure continuity across network environments.